Okay, this podcast is over finding the zeros of a quadratic function and then also finding the axis of symmetry of the parabola. So first off, what it means to find a zero of a function. A zero of a function is an x value that makes the function equal to 0. So the zero of a function is the x value that makes a function to the 0. So go ahead and add this to your words worth knowing part in your notebook. Really what this means is we are trying to find where the graph crosses the x-axis. That is the zero of a function. Okay, to find the zero of a graph, what you need to do is just look at the graph and see where it appears to be crossing at. So it looks to be crossing at -1 and 3. So we are going to check that in the quadratic equation that was given. We are going to plug it into our x value. So let's plug in -1. Make sure you always plug these in parentheses and solve. When you plug in -1, you do get 0. Check, so that one works. So now let's try 3. That also equals 0. So check. These are your two solutions. Again, the reason why we're getting 0 is because this ordered pair is -1, 0. This ordered pair is 3, 0. So when we plug those in, we do want to get 0 for our y value. All right, let's look at this one. This one is only crossing once because the vertex of the graph lies directly on the x-axis. So let's try that. That appears to be -4. So let's plug in -4. When I plug in -4, it does equal 0. Notice that if a parabola only has one 0, the 0 on the x-coordinate is the vertex. So remember I said if there's only one 0, then that 0 has to be the vertex. Okay, how about this one? Now looking at this one, it does not cross the x-axis at all. It does not cross that line. Therefore, there are no zeros of this function. There are no zeros. Now the next thing I want you to add to your words worth knowing is axis of symmetry. A vertical line that divides a parabola into two symmetrical halves is the axis of symmetry. So a parabola looks like this. The axis of symmetry is going to divide that parabola in half. So if the function has one 0, the axis of symmetry lies on the vertex. So if it has one 0, this axis of symmetry lies on the vertex. If a function has two zeros, looking at this function here, to find the axis of symmetry, you have to find the average of the two zeros. So you take the x values, you add them together and divide by 2, like they have done here. So let's do some examples. Okay, letter A. The axis of symmetry seems to lie right on the vertex. It says it's only crossing it once, so I don't have to do any averaging. So that vertex point is -1, 0. Therefore, the axis of symmetry, that line that divides it in half, is x equals -1. The axis of symmetry is always the x value. Okay, example number 2. I have two zeros on this point. My zeros are 1 and 4. So when I have two zeros, I want to take the average of the two zeros. So I add them up and divide by 2. So 5 divided by 2 is 2.5 or 2.5. So it would lie 2.5. Sometimes they don't give us a graph. So if they don't give us a graph, we need to use the axis of symmetry. Please make sure this is written somewhere in your notes. X equals negative b over 2a. Now, where they get this a, b from, our quadratic equations in standard form is y equals ax squared plus bx plus c. So a is the number in front of the x squared, b is the coefficient in front of x. And we are not going to be using the c value right now, but we will in the future. Okay, so let's try this. First thing that we need to do is identify the a and b values in an equation. So I'm looking at this example they have up here. Remember, the number in front of x squared is a, number in front of x is b, and the last integer is c. So I'm going to use these formulas. So a equals negative 3 and b equals 10. I'm going to use this formula to plug in my values. Now, make sure you see that we have this negative out front. So when I put all my values in parentheses, that helps me to identify what I'm entering. And then, so I put b over 2a is negative 3. Okay, so I'm going to simplify. I have negative 10 over negative 6, which ends up being 5/3. So the axis of symmetry is 5/3. Okay, next my a is 2, my b is 1. You know, there's no number in front of the x, which means it's a 1. So in my formula, x equals negative 1, and negative b over 2a is 2. So I have negative 1/4. So my axis of symmetry is x equals negative 1/4. This next part is finding the vertex. And the vertex point is, we're going to follow the same that we've been doing, find the axis of symmetry. So we're going to use the formula, x equals negative b over 2a. And then we're going to take the solution of x and plug it back into our quadratic equation that was given. So let me do this. All right, so the first step is to find the x coordinate. So by doing this, I'm going to first identify my a and b values. A is negative 3, b is 6. I'm going to use the axis of symmetry formula. So x equals negative, and then insert 6 over 2 times negative 3. So I have negative 6 over negative 6, which equals 1. Right? So there's my first step. This is x. X equals 1. I found my x coordinate. Oops. Now step 2 is to take my x coordinate and plug it back into my original equation, which I must have deleted it. So I'm going to take this and plug it back into my original equation. So y equals negative 3 times 1 squared plus 6 times 1 minus 7. And I solve for my y, and I get negative 4. So the last step is to write it as an ordered pair. So my x value was 1, my y value was negative 4. So again, this is my vertex point on my graph. So now I know where I would graph this at. All right, so this concludes the podcast for characteristics of quadratic functions. The two main points that you learned in this podcast was the axis of symmetry formula is negative b over 2a. And to find the vertex, you take this x value that you solved for, you plug it back into the equation to get your matching point.